Alright, we had Mission Impossible, and that's what the graph looks like. And question number 1 reads, you notice some things right away. There are 2 vertical asymptotes. How do they fit into the solution? Put them in. We found that the vertical asymptotes are -3 and 1. So we put that here, and this would be the denominator. But we realized that it bounces at 1, so we had to put... No, wait, that doesn't have... Never mind. Alright, number 2 says there are 2 x-intercepts. Where do they show up in the solution? Put them in. So these are the 2 x-intercepts right here. So then that is x minus 1 squared, and then x plus 3. And we have the squared there because it bounces at 0.10. So we realized it had to be even, so we just put a squared there. Number 3 says, using a graphing utility, use a graphing utility to check what you have so far. Does it look like the original graph? Notice that 1 and -3 appear to be the only real zeros. What can you tell about the multiplicity of each one? Do you need to change the multiplicity of either 0 in your solution? Our graph does look similar to the graph in the original problem, and we noticed that on the point on the x-intercept 1, 0, that it bounces, so we change the multiplicity to an even multiplicity so it bounces. So we would have to change the multiplicity of, we had to change the multiplicity of the x plus 1 in the denominator. We had to square that to make it even as well, so then the graph would have an even number of, help me out. To make it even, like x.
Oh, even degree?
Yes, even degree. Thank you. Alright. Number 4, how can you account for the fact that the graph of the function goes to -infinity on both sides of one vertical asymptote, and at the other vertical asymptote it goes to -infinity on one side and to infinity on the other? Can you change the denominator in some way to account for this? We originally had this equation where we squared that, but then did not square the bottom, so then it would not have an even number of an even degree. So then we changed it by squaring x plus 1 to give these both a degree of 3 on top and bottom, which made the graph give that trumpet shape to it. And number 5, give your end result in factored form. So our end result is x minus 1 squared times x plus 3 divided by x plus 3 times x plus 1 squared.